All right, we want to find this part B part, the area of the region that lies outside of the loop this time. So in part A, we found the area of just the loop. So now let's find the area outside the loop, and that includes these little slivers down there at the bottom too. All right, so we want this little area, even those little slivers down there at the bottom. So I want the area outside the loop of the limestone. Now, remember this was at 7 pi over 6, and this right here was at 11 pi over 6. So going from, if you want to call this negative pi over 6, going from negative pi over 6 around to 7 pi over 6 does this part. And then in between here is what maps out the loop. So going from 7 pi over 6 to the 11 pi over 6 does the little loop in here. All right, now you have to remember the way this happens is, think of this as a lighthouse again. When you have a light shining from the pole here and it's shining out this way. So if I start at negative pi over 6 and I have this light shining out from here, notice it's covering up the loop. So if I do the area from negative pi over 6 around to 7 pi over 6, that is also going to give me the area of this loop as well as the green part. So to go from negative pi over 6 to 7 pi over 6, I will need to subtract off a loop. So I'll do the area and then subtract my answer from 3a. Now, if I went all the way from 0 to 2 pi, went all the way around, it's going to map on top of this inner loop twice. All right, because it's mapping out the big area first, and then when you go from 7 pi over 6 to 11 pi over 6, it comes back and maps in the loop. So going from 0 to 2 pi goes on that loop twice. So you could do the integral from 0 to 2 pi and subtract double our answer in part A if you wanted to. Okay, or you could just do going from negative pi over 6 is what I would call it, around to 7 pi over 6, and then that would only make you subtract off one loop, which is what I'm going to do. All right, I'm going to do, and I'm not even going to do that much. I'm going to do negative pi over 6, and I'm just going to go to pi over 2, and then I'm going to double my answer. So I'm going to go from negative pi over 6 to pi over 2. That'll just be this right half. I will double that answer, and then I'm going to subtract off the loop. So this is what my area would look like. I'm going to double my area of 1/2 the integral from negative pi over 6 to pi over 2 of my r squared, 1 plus 2 sine theta squared d theta. And then I'm going to double that area. Then I'm going to subtract off the one loop, which will be my answer to 3a. I'm going to have to subtract that off. All right, so the reason I do that makes it nice because then that gets rid of that 1/2, because I'm only doing the area of this right side from negative pi over 6 to positive pi over 2, only does this right side, and then I double it, and then I have to subtract off the loop, okay? Instead of doing the whole thing from 0 to 2 pi and having to subtract 2 loops, which you can do that, and 0 to 2 pi would be easy to calculate, because plugging in 0 and 2 pi are pretty easy values. But then you'd have to remember to subtract double the answer in part A, because it maps over the loop twice. But I like to do half of it, and then that cancels out my 1/2, which makes that a little easier. All right, so I'm going from negative pi over 6 to pi over 2. I got to square this out, so square the first term, multiply these together and double it, so that'll be 4 sine. Then square your last term, 4 sine squared, and d theta, and then I need to remember to subtract my answer in 3a. All right, so I'm going from negative pi over 6 to pi over 2. I've got 1 plus 4 sine, and I need to put in place of that sine squared, 1/2 minus 1/2 cosine 2 theta. That's that substitution that we do, minus 3a. All right, so this is going to give us negative pi over 6 to pi over 2. Half of 4 is going to be 2, so that's going to make that 3 plus 4 sine, and then minus 2 cosine 2 theta, which is nice that 2 is needed to do the antiderivative, minus my answer to 3a. So my antiderivative is 3 theta. The antiderivative for 4 sine, the antiderivative of sine is negative cosine, minus the antiderivative of 2 cosine 2 theta is going to be sine 2 theta, because the derivative of sine is cosine, and you will chain on the extra 2. So that's nice that that 2 is there. So that's going to be from negative pi over 6 to pi over 2, and then I got to remember to subtract my answer to 3a. So now I'm doing the big old fundamental theorem of calculus. Hopefully I can plug all these numbers in here. Pi over 2, so 3 pi over 2 minus 4 cosine pi over 2 minus the sine of double that, which would be pi. And I'm going to make that bigger because this one probably take me more space to write out. I don't know. All right, so then minus, now we put in negative pi, so that would be negative 3 pi over 6, putting in negative pi over 6, minus 4 cosine of negative pi over 6. And then minus sine of double that would be negative pi over 3. And then I got to remember to subtract my answer in 3a. So this gives me 3 pi over 2. The cosine of pi over 2 is 0. The sine of pi is 0. And so then this is going to be plus pi over 2. And this will be plus 4 times the cosine of negative pi over 6. So where are we on the unit circle if we are at negative pi over 6? All right, negative pi over 6 is negative 30. So that's going this way 30 degrees. So that means I'm over a lot, down a little. And I want the cosine, so that would be over a lot, radical 3 over 2. And then distributing my negative still, so that would be a plus. And I need the sine of negative pi over 3. Well, negative pi over 3 means I'm negative 60. I meant to change my color. Negative 60 degrees, that puts me down here. So I'm over a little, down a lot, and I want the sine, so that's the down a lot, negative radical 3 over 2. So I've got 3 pi over 2 plus a pi over 2 is 4 pi's over 2, which is 2 pi. And then 4 halves radical 3 minus a half will be 3 halves radical 3. And then I've got to remember to subtract my answer to 3a. So my answer to 3a was pi minus 3 halves radical 3. So that'll be 2 pi minus a pi will be pi. And then this will be a 3 halves radical 3 plus a 3 halves radical 3, which will be 3 radical 3. So there's my answer to part B, where I found just the area of the part, just the area of the part on the outside of the loop, this green part. So I did the area from negative pi over 6 to pi over 2. I doubled it to get this other half over here as well, but that includes this loop. So then I had to subtract my loop answer from 3a to get just the green part. Just the green part. All right. So this next question, I think we probably just already done. All right, if I'm thinking correctly. 3C says find the area of the region inside the limacon. So when they say that, they want the whole area, this whole area. So if I did that, that would be the part I just did in part C or part B where where you don't subtract the loop. So I could do, because that includes the little pieces down here at the bottom too. So again, that would include the negative pi over 6 around to 7 pi over 6 if you wanted to just do that. And then that covers up that one loop too. So that gives me just the area inside. So you could do 1/2 the integral from negative pi over 6 to 7 pi over 6. And then r squared 1 plus 2, 1 plus 2 sine theta squared. d theta. So that's really what I just did in the previous problem, except I chose to do negative pi over 6 to the power 2 and just double my answer. All right, and then that in the previous problem we didn't want the loop, so then we subtracted off the loop. So this problem is exactly the same. I just wouldn't have to subtract off the loop. All right, but if I chose to do it this way, I'm going to get the same answer, and I'm going to do it just because I want to do it. So I'm going from negative pi over 6 around to 7 pi over 6. That does include the loop, because remember, if you go all the way around to 2 pi, that covers the loop twice. All right, so this time I want the area inside, so I do want the loop this time. So this will be 1/2 the integral negative pi over 6 to 7 pi over 6. And then I have to square this, so it gives me 1, multiply and double, and then square this will be 4 sine squared d theta. So now I can do my substitution and distribute my 1/2. So that's going to be negative pi over 6 to 7 pi over 6. That's going to be my 1/2. That'll be 2 sines. And then I'm going to distribute that. It'll be 2, but I need to replace my sine squared with 1/2 minus 1/2 cosine 2 theta. Notice I've used that every single time because we've done sines and cosines. So I've replaced, and you have to square it when you're doing the area. So I've had to do that every single time. All right, negative pi over 6 to 7 pi over 6. This is going to be 2 times 1/2 is 1. 1 with this would be 3/2 plus 2 sine. And then this will be a minus, that'll be a 1, so that'll be minus cosine 2 theta d theta. So now I'm ready to do my antiderivative, so that'll be 3/2 theta, because that's the variable I'm using, plus 2. The antiderivative of sine is negative cosine, so I'll need to change that to a minus sign. And then minus the antiderivative of cosine is sine 2 theta, but remember chain rule, so I'm going to put a 1/2 in front of that to cancel to get me a 1 up here. And then I'm going to evaluate from negative pi over 6 to 7 pi over 6. So now I can do my fundamental theorem of calculus, make big parentheses because it takes a lot of work to do it. All right, a lot of space. So putting in 7 pi over 6 first, this will be 3/2 times 7 pi over 6 minus 2 cosine 7 pi over 6. And then minus 1/2 sine, and we're doubling it, so that'll be 7 pi over 3. Then we're subtracting, putting in the negatives, so 3/2 times negative pi over 6 minus 2 cosine of negative pi over 6 minus 1/2 sine of double that, negative pi over 3. All right, so now we're doing our algebra. So this is going to be 7 pi over 4 minus 2. All right, we need the cosine of 7 pi over 6, which that's going to be 210. So remember, 2 tens over here, cosine's over a lot. So that's going to be negative radical 3 over 2. Minus 1/2 the sine of 7 pi over 3. Now 7 pi over 3 is more than 2 pi, all right, because that's 2 1/3. So that means I've gone a pi over 3, which is up here, pi over 3, that's pi over 6. So it means I'm over little up a lot, and I'm doing the sine, so I'm up a lot. So that's radical 3 over 2. And then this is going to be plus when I distribute that across, pi over 4. This will be a plus when I distribute that. And now I need the cosine of negative pi over 6. So negative pi over 6 is going to be down here, negative 30 degrees. So I'm over a lot, down a little. I want the cosine, so that's over a lot, radical 3 over 2. Minus 1/2 the sine of negative pi over 3. So negative pi over 3 is down here, over a little, down a lot. I want the sine, so that's the down a lot, negative radical 3 over 2. So I've got 7 pi over 4 plus a pi over 4 is 8 pi over 4, so that's 2 pi's. And then here, this cancels, so that's going to be a plus radical 3. This over here cancels, that's a plus radical 3, so that's plus 2 radical 3's. And then here we have, I'll write it so I don't make a mistake, negative radical 3 over 4, and then another negative radical 3 over 4. So this is going to be 2 pi. So this is going to be minus 1/2. So 2 minus 1/2 is 3/2. So that'll be 3/2 radical 3. So here's my answer. 2 pi plus 3/2 radical 3. Now, you can double check and you can look at the answers and check that, again, Math 9, the original integral, and see if we get the decimal equivalent for the answer that we got down here, 2 pi plus 3/2 radical 3. All right, so the interesting thing about the limacons that you have to remember is that if you go full around 2 pi, you've gone across this loop twice. So that's the tricky part of doing a limacons area, is because if you don't want that limacons area, you have to subtract 2 loops if you go 0 to 2 pi. So that's the tricky part. That's why I wanted to make sure I covered the limason pretty good, because that one's the trickiest one. All right, and this last problem is kind of cool, so I just wanted to do it real quick. All right, find the area of the region inside the rows. So we want inside the rows, but outside the circle. So we want these areas out here. Inside the rows, but outside of the circle. So I want the area of these 4 little tips out here. All right, so the easiest thing that we can do to do this problem is if I figure out this intersection point and we go from 0 around to this intersection point and then multiply it by 1, 2, 3, 4, 5, 6, 7, 8. So if I find the area of just this little piece right here, then I can multiply that answer by 8. So I just have to figure out where is this intersection right here, okay? So that's where you're going to set these equal. Set 4 cosine 2 theta equal to 2. So that means cosine 2 theta is 1/2 when you divide by 4. So where on the unit circle, so my 2 theta equals, where on the unit circle is cosine equal to 1/2? So cosine is equal to 1/2 at pi over 3. All right, and so then when we divide by 2, that gives you theta is pi over 6. So this answer right here is pi over 6 for where they intersect right there. And there's a whole bunch of answers because they intersect 1, 2, 3, 4, 5, 6, 7, 8 times. So of course pi over 3 is not the only answer where cosine's 1/2. It's also 1/2 at 5 pi over 3. And then if you add another 2 pi, you get 7 pi over 3 and 11 pi over 3, and you can find all the intersections like we did on another problem in another video. And then the way to get the other 4 answers, remember, was to represent r as a -2. So a circle of 2 is the same as a circle of -2. And so the other way to get the other 4 answers would be to set 4 cosine 2 theta equal to -2, and that gives you your other 4 intersection points. But we only needed that one. We only needed the pi over 6. So what are we going to do? We are going to find the area of just this blue part, which is now pink that I colored in. We're going to go from 0 to pi over 6. So we're going to do 1/2 the integral from 0 to pi over 6. Now, what do we find in the area of? We've got this area here, but it's white underneath. So I'm having to do a big R squared minus the little r squared. So who is my function further out? Well, that is the rows. So that's going to be the 4 cosine 2 theta. And then the function that's closest is the red circle. So that's going to be my little r. So the red circle is 2. Now, this is only going to find one piece or half of a piece. So my area I'm doing here is not my whole answer. I've got to remember that when I get to the bottom. So this will be 1/2 the integral from 0 to pi over 6. I'm going to square this. So that's going to give me 16 cosine squared 2 theta minus 4. Well, that's pretty easy. So let's go ahead and distribute the 1/2 across and get rid of that 1/2. So 1/2 will be 8 cosine squared 2 theta minus 2 d theta. All right, then I also need to get rid of the cosine 2 theta, the cosine squared, because it's a squared. So I need to replace that with the 1/2 plus the 1/2 cosine. But remember, since this is 2 theta, it's going to be 4 theta in my replacement minus 2 d theta. All right, so now we're going to end up with 0 to pi over 6, multiply through by 8. We're going to have 4 plus 4 cosine 4 theta, which is going to be nice, then minus 2. Let me go ahead and minus 2. So let's just make that a 2. D theta. So now we're ready to do our antiderivative. The antiderivative of 2 in terms of theta will be a 2 theta plus the antiderivative of cosine is sine 4 theta. And remember, we're going to end up, when we take the derivative of this, we're going to end up multiplying by 4. So that's where that 4 is going to come from. So that's my antiderivative, and I'm going from 0 to pi over 6. So that's all I'm doing the antiderivative of. So this one's not a very hard one. So now we're going to do our fundamental theorem of calculus. So I put a pi over 6 in, so 2 times pi over 6 plus sine of 4 times pi over 6. And then plugging in a 0, that's going to be a 0. The sine of 0 is also going to be 0. So all that goes away. All right, so this is going to be pi over 3. And then I just got to figure out what is the sine of 2 pi over 3. So 2 pi over 3 on the unit circle is 120. So it's over a little, up a lot. I want the sine, so that's the up a lot. So that would be radical 3 over 2. So there's my answer. Pi over 3 plus radical 3 over 2. And remember, when we go back up here, that's only this area right here. So I want all of the area outside the circle, but inside the rows. So I only did this 1/2 piece. So I need to multiply it by 1, 2, 3, 4, 5, 6, 7, 8. So I need to multiply it by 8 to actually get the answer to the question. So my actual area to the question is 8 times pi over 3 plus radical 3 over 2. So my final answer is going to be 8 pi over 3 plus 4 radical 3. So that is my final answer to the question on the area of outside the circle, but inside that 4-petaled rose. So think of just patterns and ways that you can get the areas a little easier, like finding a portion of it and then doubling or multiplying by 4 or however many pieces there are. So like in this problem, I just did that one little piece, and then I know these are all equal to each other. So then I was able to multiply it by 8 to get the actual final answer to the question. All right. So when you're doing area with these, you can do half of something and double it. So you don't just have to always do the integral of the whole thing that you're looking for. So just remember there's different strategies for being able to find the area. So I hope these extra area videos were helpful. I think doing more examples is beneficial, but I'm hoping that they're helpful for you, that you're understanding it a little better now.